Okay, so in the interest of time, I think we should go ahead and get started. I have a feeling that a lot of people will start joining here in the next few minutes, but just to remind everybody, you have 25 minutes to present and 5 minutes for questions. We ask that when you see a question in the chat, just read the question back before answering it. That way it gets captured in the recording. I will upload the link to the peer review presentation form again into the chat. So everybody in the class should be filling out a form for the other people in the class. They're really pretty brief, so it shouldn't take you very long. Since there are only 10 people in the class, you'll only have to do 9 others. Like I said, you can, if you weren't able to make it on Friday, you can find those the recording of those in the Capstone Library, which the link is there. So we can go ahead and get started. So Austin, whenever you're ready, feel free to start.
Okay, great. Well, thank you for everyone for joining me. This is my proposal presentation. I'm going to be covering shadow reclassification in aerial imagery by correlation of spectral compositions. I'm proposing a fairly novel approach to uncovering land cover types underneath shadows based on the spectral compositions of those shadowed objects. So in object-based imagery analysis, or OBIA for short, land cover classifications are undermined by shadows inherent in remotely sensed imagery. In the context of urban mapping, a significant portion of the scene can be hidden, resulting in inaccurate land cover measurements, which could affect urban development, utility planning, and environmental mitigation. As land cover mapping utilizes higher spatial and radiometric resolutions by means of aerial or drone imagery, a side effect is that the shadows become more detectable and therefore pose a greater challenge when attempting to ameliorate these areas. When using an OBI approach to classify land cover, objects are generated based on spectrally similar values. So reflectance values of these objects are then aggregated and then classified based on the known characteristics of the land cover type. And this also includes shadows, which typically offer very low intensity because of the lowered reflectance captured by the sensor. What I found out in my research is that although shadows have a lowered intensity when compared to fully illuminated areas in a scene, the land cover's spectral composition remains constant regardless of the intensity of those spectral signatures. So this figure shows us an example of the spectral intensity between a fully illuminated tree and a tree that has a shadow casted over it. And typically with vegetation, we see a near infrared band value that's much higher than the red value. So that spectral composition is what you generically see for vegetation. And what's found is that you find that same identical composition with the tree that has a shadow covering it. It's just that the relative intensity of all of the reflectance is much lower. So my solution to this problem is therefore to derive correlation coefficients that can identify spectrally similar objects in shadowed areas to known land cover types. So by correlating spectral compositions within shadows to spectral compositions of known land cover types, land cover beneath shadows can then be predicted. So my proposal entails using the Pearson's R correlation test to match unknown shadowed objects to known land cover classifications based on that object's spectral metrics. So by identifying which shadow objects are most similar to any given land cover class, a simple reclassification can then be used to remove those shadows. So this figure here is an example of my proposed methodology. So if we continue with the tree example, essentially what I'll be doing is taking a collection of known tree objects, and I'd be aggregating the spectral values within one standard deviation. And what I'd get is a representative tree object. And that would this here would be the spectral composition of that tree object. And I would use that in the correlation tests against each shadow object. And what would be derived are the coefficients. And by simply creating a threshold, I could filter out all of the high positive correlated shadow objects, and those would be reclassified therefore as trees. I implemented this proposed methodology on a small sample size of 100 ground truth shadowed objects. And this is part of a proof of concept to show the methodology. So part of this presentation will be showing the results of this POC and talking about how I'd like to scale this project to a larger study area. For the final portion of my capstone, which will be finishing up this summer, I'd like to attain 500 ground truths, so a much larger sample size, so I can assess the model and go from there. So moving into the data that I'll be using. So first off, I will be working with NAPE aerial imagery of 1 meter spatial resolution. This imagery has 4 bands, red, green, blue, and near infrared. And the imagery will be of Boulder, Colorado, and it encompasses approximately a 4x4 mile extent. Boulder, Colorado is a small sized city, which is primarily made up of residential neighborhoods and outlets. I chose this as my study area. It is the city that I live in and allowed me to test my methodology by implementing the ground truths that I just talked about and assessing the accuracy of the model. So this portion of the NAPE imagery shows the central district of Boulder, the downtown district, I guess. If we look at the color infrared of the NAPE imagery, we see that the majority of the vegetation is within the residential area and actually consists of the majority of the shadows that are casted. The University of Colorado Boulder campus is here, and a lot of the shadows are casted from the tall structures you see here. And so, moving forward, besides the NAPE imagery, I'll be using a normalized digital surface model, and that'll be built from LiDAR. This for my POC was created in ArcGIS, and it is also of 1 meter spatial resolution. So it'll match up with the NAPE imagery nicely. So the first phase in the workflow will be to build the initial classification. So this will be conducted in eCognition, where I will segment and then classify the imagery. And the hope is to obtain at least a 90% accuracy rate overall. And I'll be using fairly broad land cover classes as seen here, buildings, pavement, trees, grass, bare earth, and of course shadows. Now I could have gone a little bit deeper into each classification, but I'm restricting that because I'm using a fairly low radiometric resolution imagery data set, which is the NAPE. NAPE imagery is at 8-bit radiometric resolution. So, the ability to capture spectral variance within each pixel is fairly low. And so moving forward with the NAPE, wanting to keep those classes as broad as possible without sacrificing too much of the land cover seen in the NAPE. So here's an example of the initial classification that I've already conducted, and it's laid over the NAPE. And so again, the shadows are highlighted here in yellow. And for the POC, I went ahead and did an accuracy assessment. And this is what I'll need to do when I grow my sample size to 500 shadow objects. But what I did here is take 100 samples per class. And this was chosen directly from the NAEP imagery. And then use those ground truths to assess the accuracy of the initial classification. So if we just look at shadows, here's the spatial distribution of those. So this is basically saying that out of the 100 shadow objects, only 10 were misclassified. So next is an error matrix that breaks down each class's producer and user's accuracy. So again, we're seeing an overall accuracy rate of 90%, which means that out of the 600 samples that I chose, 539 were correctly classified. So this would be a good threshold to use moving forward and scaling this workflow to make sure that I'm getting at least 90% before moving forward. The spectral metrics that would be critical in not only the initial classification, but also the correlation tests are listed here. So all the bands of the NAEP imagery would be utilized, as well as the normalized digital surface model. Included in these sets of metrics are some custom metrics that I calculated that I found to be extremely useful in determining the initial classification. These help clearly differentiate vegetation from impervious surfaces much better than the conventional NDVI metric. So those custom metrics are listed here. So I have an NIR red ratio, which I found to be a little bit more effective in differentiating vegetation from impervious surfaces than the NDVI metric. I also included an NIR red difference because that normalizes the intensity that would be found between fully illuminated areas and shadowed areas. And so for vegetation, for example, we should see relatively the same amount based on each land cover type. So again, for the correlation test in this POC, I physically went out and ground truth each shadow object that was initially classified. And this is the spatial distribution of that, and then the land cover type. So as you can see, the majority of the land cover beneath each shadow was in fact pavement, especially in this downtown district here. And then a lot of grass in the neighborhood and the campus further south. So for the actual correlation tests, I will be processing the vast amount of objects that are pulled out of eCognition using a data analysis package in Python called Pandas, along with its spatial extension GeoPandas. Both are open source libraries capable of all sorts of tabular and spatial manipulation. So this diagram here really helps in explaining how the coefficients are going to be generated in Python. So for example, the tree class on the left will be formatted into tabular format along with the shadow class on the right, and those in Python are called data frames. Then I will use the pandas core width function, which generates Pearson's R coefficients based on the two data frames' relationship to each other. So the first row in each data frame will be matched so that the red from the tree data frame is run against the red from the shadow data frame, and so on and so forth. So this will generate a coefficient for each row in the data frame using the same index as those corresponding data frames, which means that when eventually selecting the high correlation values, there will be an index to reference from, and we'd be able to use that to select the objects and then thereby reclassify them as shadows. So I'll be conducting this analysis in a Jupyter notebook. This script here goes over the POC results. And I can quickly go over some of the key points in this script. Don't need to go over every single line. But the main idea behind this script is to do the correlation test, like I said, but also do some formalities such as data cleaning and organization of schema. What's really important with the core width function is that the schemas for each data frame need to be identical. So this chunk here, which is one of the key chunks here, is generating the representative tree object. And in this example, I'm using the tree object, but it would be for each land cover class. And that's generating random spectral values within one standard deviation of the mean that's found in the collected objects that I pull from eCognition. So this tree core, this would be the representative tree data frame that I would use against the shadow data frame. So as you can see here are all the spectral metrics that I pulled out. And with that, here's the shadow data frame with the same exact schema and so forth. The only thing that is not listed here is the land truth that I pulled out, but I would be reintroducing after the correlation test. And then when conducting the core width function, these are the coefficients that would be generated. And so as you can see, each row has a coefficient. And then moving forward using a threshold. In this example, I used a threshold of 0.75 or anything higher. I believe when scaling up this this project, I'll probably be using a higher threshold. But essentially, what would happen is I'd select the indexes that had a high enough correlation, and this is what I would get here. So for this example, we see that it did indeed pick a good group of trees. In fact, there was only 6 trees in the sample size. And so it looks like it picked, what is that, 5 of them, 5 out of 6. So I ran this a couple times to see kind of what the results would vary based on each land cover. But we can move forward to the results. So the final results are here. Again, this is the spatial distribution of the sampled shadowed objects that I pulled from the NAPE imagery and then ground truthed. And these are the results of the correlation tests. So I was able to get an 80% accuracy rate, which was pretty good. So if we go here, you can click on this map and it'll show you that for this point, the land truth was pavement and the correlation test selected as pavement, so it's correctly classified. If we go to a misclassification, for example, this one, it says it was supposed to be grass, but the correlation test selected it as trees. Moving forward to the error matrix of this POC, one thing to point out again is that the sample size per class was not equal. And you can see that here in the total row. So the majority of those were pavement, which is going to be expected. I'm not going to be able to get a completely equal sample size per class. But as you can see, the accuracy varies quite a bit per class, but overall, we're still seeing that 80% accuracy rate, which is pretty good. And I like to keep that the threshold moving forward when scaling this project. So moving forward, two of the biggest challenges that I see is first off, if a shadow object is selected more than once. So for example, if a shadow object is selected as both tree and building. And so a potential solution to that is to capture each shadow object's proposed selection. And that would be in memory through Python, and then rerun the correlation tests on any objects that have more than one class. And that correlation can be rerun multiple times. And then by choosing the class that has that occurs most often or has the highest selection rate, that would be the class that we would therefore reclassify the object. Another big challenge moving forward is processing speeds slowing down. So for the POC that I presented here, I only dealt with 50% of the nape tile. So moving forward to scale this to a full nape tile would involve subdividing subdividing the imagery into 4 parts. That reason to do that is because my objects per class were around 1 million. So quite a bit of objects. And so just reaching a size capacity issue is going to be a big challenge moving forward. So subdividing that nape imagery into 4 parts would be a good start, and making sure that I keep those objects well within the shapefile size capacity. So next steps, just to summarize everything here, first and foremost is to refine that Python code that I showed to accommodate for multiple class selections that could potentially happen during that correlation test. And then also scaling the nape imagery. So subdividing the nape imagery and then having to rerun that entire script at least 4 times. And then assessing the accuracy at scale. So like I said, moving from 100 ground truth to 500 ground truths, I think would be more effective with that original nape tile. And if the accuracy is at least 80% or better, then I would feel comfortable assessing the accuracy in another study area, particularly looking at an area that has more urban development or a metropolitan area that has much larger structures. So yeah, so that's about it, everyone. I hope everyone enjoyed my presentation. I'm going to have the story map posted, but I will have the Jupyter notebook posted on my GitHub for anyone who's interested in playing with the code and all that. So yeah, I'm happy to ask any questions that people have. Thank you.
Thanks, Austin. Great presentation. While we're waiting for, it looks like we already have a question. So it looks like Pat has a question.
All right. So Pat asks, I would assume shadows modify color, darkness, aka lightness, value, intensity the most. Have you tried converting RGB imagery to IHS, intensity, hue, saturation, color space, to see if you can see any trends with intensity? So yeah, so I actually did for my project in 868 a couple terms ago. That was actually my proposal for ameliorating shadows, which was to play with that intensity. So, you know, stretching the color histogram in different ways, or converting it, like you mentioned, to IHS. And there's a lot of research that's been done that does this certain methods, but the majority of it really is for visual aesthetics. So to take an image and to visually ameliorate those shadows and to visually remove them, indeed is pretty effective. But when you're using an OBI method of classification, it's very difficult to correctly classify the land cover underneath the shadow, because what you're dealing with is the spectral values, not necessarily the visual aspects of it. So that's why when using an OBI, I needed to figure out a different way, because like I said, the spectral composition, regardless if it's in low light or in full illumination, it's the same composition. You'll see that. So trying to figure out and identify that was sort of the scope of what I was trying to do. Steve asked, do you know how many images across your area of interest you will have, and if there are multiple images collected with different lighting conditions? Or are you doing anything to normalize the spectral and radiance values before performing your classification algorithms? Yeah, that's a good question. But like I said, I'm really running into space issues because I'm dealing with so many objects. So for my capstone, I'm really going to limit it to one nape tile. So hopefully I don't have any sort of differences in lighting conditions and so forth. Justin asks, I love notebooks for Python, but I'm curious why you chose this as your IDE. Well, Jupyter Notebooks is really great for data exploration because you can mark up your notebook, you can run cells individually, which is huge, I think. So just having that explorative capability, it's much better than using, other IDEs where you have to rerun the entire script. You can just rerun one cell at a time, and I find that to be just it performs a lot better, and it's just a lot easier to work with. Fritz asks, I was wondering how you were planning to select your 500 sample points, and how will you determine your correlation coefficient threshold value? So I'm going to be basically taking that original NAEP imagery and selecting 500 shadows in that imagery, and then physically going out and ground truthing them. So the same process that I did for the 100 sample points, I'm going to be doing that times 5. And I'm still trying to work through a coefficient threshold value. That's a good question, and I'm not really sure. I have found that the land cover truths that were correct were pretty high. I would say most of them were over 0.8. And so maybe I will use that. But yeah, moving forward, I haven't really solidified that yet. Max mentioned or asks, is that the specific accuracy standard that's used in the industry, 80% accuracy? That's a really good question. I don't really know I don't even know if there is a standard. In OBIA, I have noticed that in a lot of the research that the accuracy is variable, and especially in urban environments, I haven't seen a lot of OBI methods that have a 80% or better classification rate. So I don't know if that's the standard, but for me moving forward, I like to just go with that. But there is no like standard or reason for that number there.
Hey, great job. Lots of good questions.
Yeah, no, I appreciate it. Thank you, everyone.
Thanks very much. And if you want to go ahead and stop sharing, Brittany, you can start sharing and start whenever you're ready.
Okay. right. All right, can everyone see that?
Yes.
Okay. Well, my name is Brittany Haywood. I work for the Delaware Department of Natural Resources and Environmental Control in the drainage program, more specifically the tax ditch program. And my capstone proposal project here has to deal with an initiative I've taken on at work that deals with the integration of Delaware tax ditch drainage organization information into our statewide enterprise GIS. So over the course of this presentation, I will give you a background into what in the world a tax ditch is, some of the issues that we have to address, what the capstone project will consist of, some examples of the implementation of the project, timeline for it, and then the expected outcomes. So first of all, what is a tax ditch? Well, it's a ditch that has a tax associated with it, but moreover, it is a watershed-based drainage network, i.e. ditches, that are designed to remove water off the land. Each watershed drainage network is called an organization, and it is formed under Delaware law as a governmental subdivision of the state and has all of the powers blessed upon it via that law. But the unique thing about it is that these organizations are made up of and ran by the landowners who lived within that watershed. These people are called taxables. And these taxables elect officers from their pool of folks. And these officers are the only folks that can make the maintenance decisions regarding these ditches. We, the Delaware Department of Natural Resources and Environmental Control, called DENREC, and county conservation districts assist these officers with making the decisions. And I will note that these officers are all volunteers for the most part. They're doing this as a side job. And the ditches they have to maintain can look like anything you see here: open channels running through forests, they run through agricultural lands, they can be completely piped systems, they can run through housing developments. They come in all different shapes and sizes. And across Delaware, there are 234 of these tax ditch watersheds / organizations, and they equate to about 2,000 miles of channel. There are only 3 counties in Delaware. Sussex is the southernmost county and has the most amount of tax ditches and mileage, followed by Kent in the middle and Newcastle at the top. This screenshot you see here is an example of our Delaware tax ditch mapper. It is available to the public for anyone to go and type in their address and see if they are located within a watershed, if they have a tax ditch on their property or right away. However, the only attribute data we have associated with that right now is what you see in this white box in the map. So we have the name of the tax ditch. In this case, it's Georgetown Bond. The segment name, which is whether it's the main channel or if it's a prong or sub prong. The bottom width of the ditch, in this case, is 7. And then the width of the right of way, which is 55 feet CL center line, and its associated documentation, which is the COC number 1. So we have lots of information about these systems, but this is currently all we have available to the public GIS wise. A little bit of history about these systems is most of them were dug or used with blown up with dynamite, as seen in this picture here, between the late 1700s and the late 1980s. The tax ditch law wasn't established until 1951, however, when there was a need to create a uniform system to maintain these drainage systems. And then production or creation of these tax ditches kind of slowed down drastically in the late 1980s due to changes in the Clean Water Act and how the waters of the US was defined. But the thing to note here is that out of the 234 tax ditches, all of them were formed during these timeframes where the most prevalent data source or tracking was paper forms. So we have all of this paper documentation that's from these timeframes that, as of actually last week, we just all got converted to PDFs. and it's all been sitting in file systems. And that creates a challenge when trying to share information, find information, and run any sort of GIS analysis. And this matters because tax ditches impact more than just drainage across our state. So Delaware is the lowest lying state in the US. It is extremely flat. And the only way you're going to move water from one way to the other is to ditch it. I'm a biologist. I don't advocate for that, but nevertheless, there are lots of ditches. And with each of these tax ditches, there is an associated right-of-way, also called an easement. And within this right-of-way, it gives the tax ditch access to the ditch anytime, anywhere, to get to any maintenance issues, flooding, blockages. And also that right-of-way is used for disposal of any material. So if they bring a large piece of equipment in there and dip out the bottom sediment, they plop it right in that right-of-way. Therefore, that affects where structures can be built on a property. There's also a property's taxes. As mentioned, the tax ditches. They levy a fee to help pay for maintenance, and also kind of roped into where structures can be built is access by the tax ditch on private property. So the tax ditch does not own any property. They just have access to get to the ditch anywhere they need to within their own right of way. And because of all of the different areas tax ditches impact, they have a lot of stakeholders that come to the table. Now, the key stakeholders would be the officers who make the decision, DENREC, my office, and the conservation districts. These three play the biggest parts. However, the public in general is a huge role. Land use and stormwater permitting and planning agencies at the state, county, and municipality. County tax collection agencies. So the county collects the tax from the landowners and then distributes it to each tax ditch so then they can use it. The county courts. So each of these tax ditches that are created have documentation filed in the court systems. Maintenance contractors, elected officials, and the Delaware Department of Transportation. Tax ditches provide drainage for over half of the state maintained highways in Delaware. So there are a lot of different stakeholders coming to the table to make things work. And since the tax ditch law was created in 1950s, it's been updated a few times, but not a whole lot. And there are concerns about how maintenance and operations are happening, which incited the tax ditch modernization work group effort, which happened last year. This effort put together over 50 folks from the stakeholders listed before, and they met 9 times over the course of the year. And through that effort, they identified concerns and possible solutions to that. And one of the things they identified as a need was tax ditch maintenance, planning, reference materials, and resources. More specifically, they called out development of a digital GIS-based tax ditch infrastructure and conditions inventory that can easily be shared, including reports provided to officers and maintenance contractors, and also clearly defining who's responsible for what parts of the tax. In addition to that, they also defined a need to improve warrant rate recommendations, and the warrant rate is the tax rate for each organization. So each of those organizations, again, makes their own decisions regarding how much tax they're going to charge, what maintenance they're going to do. They're little autonomous organizations all across the state. But through this work group, there's kind of 3 key areas that all of the concerns fall into, and that's providing technical assistance. So again, the maintenance planning and inspection reporting, providing that administrative assistance, so that financial planning and reporting aspect. And the big one is public response. So we get lots of requests from public about what's going on in their tax ditch and trying to respond to them. We also get lots of legislative requests to try and also put reports for all of the tax ditches within their district. So all of this has kind of led to a larger scale initiative to take all of the data we have and try and put it into one area. So right now we are in a situation where we have data held in multiple formats and places. What you see in the top right is a zoomed in version of that same tack stitch mapper you saw before, and the orange outlines of the polygons, that denotes the tack stitch right away. The blue center line is the channel. So we have pretty good GIS information related to the tack stitch location. We also have lots of court documents, which is this screenshot in the center, this sunset branch tack stitch. Court order change is what they're called. It denotes changes to tack stitch. So anytime you change the location, want to change the right of way, that requires a court document to document said change. Then there's also the original maps and as-built information that were all hand drawn, and they're really awesome maps if you ever want to nerd out on some old maps. But it makes it hard to really evaluate a system-wide kind of functionality. So where we're headed is a one-stop shop to address common tasks. And that's where this project comes in. So I will say the capstone project is only a portion of this large-scale effort to have this tack stitch GIS integration, and it focuses on the request for proposals, RFP. But where I'm at currently with this project is the needs assessment portion. So we have the 2021 tax stitch modernization work group. We have information from that. I've been interviewing our staff to see what their needs are, what they would like to be able to do, what they can't do, and then also reviewing our daily tasks. I'm taking all of that information and starting to develop out the attribute tables for our geodatabases and what the needs are and where we can find that information. And then all of this information will be used to create an RFP for implementing the geodatabase design and application. And then that RFP, the deliverables will be implementing the pilot to test to make sure that what we thought we wanted was what we actually wanted and making sure it works. And then going to more of a full-scale implementation of all of the data added and implementing for all of the 234 tax stitches. So this baseline GIS data integration will allow us to do even more GIS work, including incorporating the using drones for LiDAR, and also doing a better job of watershed modeling for our tax stitches and understanding what's going on in them. But more specifically, as I mentioned, this capstone project is focusing on the RFP. So the goal of this capstone is to develop a request for proposals, RFP, that will allow the state of Delaware to select a vendor to implement the solutions to the concerns we have identified. And in that request for proposals, there will be the introduction to the project's organization, a description of our need, the scope and deliverables, the timeline, submission requirements, selection criteria, and contract terms. So the big portion of this is using all of the needs assessment and review of information to develop that scope and deliverables. So the deliverables of the RFP, the things the contractor will provide us, are the actual GIS geodatabases. So we have 6 different categories where we have layers and tables identified that we need to plug and chug and create the data and enter data and make all of that happen. So the first one is actually just setting up the databases. The second deliverable that the contractor will provide us is piloting the data entry with, we're thinking 10 ditches from each county just to get a wide variety to make sure everything works right. If it works right, then doing the full implementation along with creating an application for DNREC and Conservation District staff to retrieve information and also update it. And this involves the pilot along with full implementation. So again, the capstone deliverable is the RFP, but the pieces that are going in that RFP are what the geodatabase needs to be, what we're looking for in an application for the contractor to then take and bring us with ideas. So that's the general gist, but examples of what this looks like in the scope of maintenance operations. So those court order change documents that I mentioned. This is an excerpt from the Derrickson Canal tax ditch. You don't really need to read it, but what you need to understand is all of this verbiage denotes a change in responsibility for maintenance from the tax ditch to the landowner. And right now our workflow is that when we need to figure out who's responsible for that, we have to go through each document and determine where prong 2 from station 23 plus 22 to station 28 plus 50 is, and all the others. So it's right now it's time consuming. We have to redo the process every time because we don't have it down anywhere. Well, just as a mini pilot to see if what was in my brain would actually work, I took this information and all of the documents from Derrickson and created this map, which shows maintenance responsibilities. So the green areas are areas where the tax ditch is solely responsible. The purple areas are partially on the tax ditch and partially on the landowner. And then the brown areas are solely the landowner's responsibility for future maintenance. So here you can quickly identify where the tax ditch needs to focus their efforts on maintenance. And then building this out even further, we do tax ditch inspections. So right now I created about a year ago a survey 123 that our staff use and go out and just take points and denote a channel or structure, channel bank structures, green infrastructure practice, if there's a concern, if there's obstruction preventing access. So basically they go and just take a point and collect data about it, whether the structure is sound, whether it's failing. And then we spit out a table which just has a list of all of these and a picture. And then our staff go through and provide a summary of what they saw. But what I would like to get to a point is where we can take the information that was gathered in this report on those structures and highlight ones that are in failing condition, pair that with the maintenance responsibility so we can quickly kick out information to our officers saying, hey, here's where you need to focus on. You need to focus on prong 6, not on prong 2, because that is not your responsibility to maintain. So this is just one example of how building out our data can improve our operations and make things function more quickly. Another example is related to reaching out to legislative districts. So this is an example of something our staff put together to share with representative districts. This document took, I believe, a month to put together because every single data point you see here, where there's total of 35 tax ditches, 337 miles, there's 3 officer positions, there's it was formed in 1988, there are 80 properties. Every single number in here comes from a different data source. So the person who created this had to go and track down where that data source was and then either create the information themselves or dig it out of the dustbin of our file structure. So by implementing this integration of our data, we would be able to take something like this that took our last person a month to put together and easily spit out reports because all of this information should be in the database. So the expected outcomes here are that for the RFP in particular is that it will, excuse me, it will allow us to actually have this project completed. So we do have a lot of GIS savvy staff on hand, but we do not have the time to completely overhaul our GIS structure. So by hiring it out, developing this request for proposals, we can more efficiently use our own resources and bring someone else in to help pull everything together. In addition, it's also nice just to get an outside input and expertise to think about something you didn't think about before, provide a different viewpoint, and then just see different approaches to solving the problem at hand. So for the specific timing related to the RFP, so today doing the 596A presentation, and March through October working on development of the RFP materials, and then in 596B will be taken in the fall, possibly doing a EURISA GIS Pro presentation in October. And the goal is to have the RFP submitted to the state contracting website in December to start collecting responses and potential vendors. So that's kind of my project in a nutshell, really trying to work to integrate data that's coming from multiple different facets and put it into one place, with this capstone really focusing on developing a good RFP so that we can get reasonable and decent responses back from various contractors. And with that, we'll take any questions.
Great, thank you, Brittany. While people are writing questions, I was curious, what are these called in other states? It seems to only be in Delaware.
So Maryland does have something called a tax stitch, although it isn't formed quite like it is in Delaware. To my knowledge, the way Delaware has it set up is quite unique to the state, although there are different forms of it. But the way Delaware views them as they should be run by the people because they know what's going on in their land the most. But other, like Maryland, is run, I believe, either by the conservation districts or the county from that standpoint. So yes, they are definitely a unique.
Yeah, I'm wondering if Pennsylvania does something similar to Maryland, because I was just doing a couple searches while you're presenting, and I just can't even imagine having that many miles of, whatever ditches that, need to be maintained and people having questions about it. So it's really interesting.
Yeah, when I came to Delaware, it was 6 years ago, I started hearing about tax stitches, and I was like, what is this thing? What is this concept? And quite frankly, a lot of people in Delaware don't know what they are.
Okay. It looks like Austin has a question.
All right. So Austin, nice presentation. In the RFP, will it cover the different user permission and roles for the enterprise geodatabase? And how will those privileges be given to the GIS team and or the chosen contractor? Yes, that is a good question. So I am currently working with our state IT folks to figure out what they will and won't allow outside contractors to do, and coming up with how that fits into how the state system is set up. To that end, the state really just migrated to an enterprise system within the past, I would say 2 years, but within the past year fully. So all the systems are slowly migrating to that format, and we're trying to figure out how we all fit together. Fritz says, a very practical GIS project. Who among outside stakeholders will you solicit feedback from to help you develop the content of the RFP? And in what format method will you use to get that feedback? So a lot of that feedback we've already garnered from that tax stitch modernization work group. Those had the stakeholders, everyone in the same vein. Unfortunately, when it comes to the RFP, a lot of the content and what can be put in there is relegated to what the state contracting office will allow, as far as the terms and conditions and that sort of thing. So we can put whatever we want in there. What ends up being in there is generally often up to the contracting office. They start slashing things. But to get feedback, we will use not only our office for input, but also conservation districts. And we will reach out to a select few tax stitch officers. One of the issues we run into is the majority of our tax stitch officers are elderly and do not have computers and or internet access. So the way we are planning to set this up is our DENREC staff and the conservation districts will be the primary users and will create or spit out essentially reports that then can be taken to the officers for them to use in hand. But we will be reaching out to those select few officers who have expressed interest to see what we're missing and what to fill in the gaps with.
Okay, it looks like that might be the end of the questions. Again, great job, Brittany.
Thank you.
Yeah, it takes me back to my days before coming to Penn State, working in an engineering firm and doing, transferring all the as-built drawings into GIS and everything. So Fritz is right. It seems very practical and super helpful to the organization. Nice work.
Thank you.
Okay, so Raylan is next. So Raylan, whenever you're ready, you can go ahead and start.
Hey, can you just to confirm, can you guys see like my title screen?
Yes.
Okay, great. Then I will get started. So hello, everybody. Thank you for taking the time to be here today. My name is Raylan Caldwell, and today I will be presenting my capstone project proposal titled Evaluating and Comparing Landsat 8 and Landsat 9 satellites to map wildfire burn areas. So this is the agenda. Just go through it real quickly. We'll do an introduction to the relevance and importance of this project, go over my study area, my problem statement, review my goals and objectives, outline my expected results, walk you guys through my proposed methodology as well as my projected timeline, and then talk about a couple of presentation venues that I might present this at. So climate change and human activities have been increasing the occurrence of large wildfire events across the world, and especially in the Western United States. As these fires become more and more damaging, fire and emergency management agencies are turning to remote sensing to evaluate the impacts and effects of wildfires on communities and ecosystems. Developments improving spectral and radiometric resolutions on remote sensing satellites provides new opportunities to assess the current accuracy of burn area mapping. Technology that is continually evolving plays an increasingly important role in preventing, detecting, responding to, managing, and developing post-fire recovery plans, and remote sensing is central to this effort. Remotely sensed satellite images can be used for fire detection, active fire mapping, post-fire burn scar and burn area mapping, as well as damage assessments. As part of the National Land Image Program, the Land Remote Sensing Satellites, also known as Landsat missions, have until recently been comprised of 8 Earth-observing satellites using remote sensors to image our planet. The Landsat mission, started in 1972, is one of the mainstays of NASA's Earth observation program. These satellites were designed to be of use to fields such as forestry, agriculture, geology, and land use planning, with the choice of spectral bands geared towards monitoring land use and cover change over time. The Landsat 9 mission was recently launched this past September 2021, marking the next evolution of the Landsat program. Landsat 9 improvements include higher radiometric resolution across the visible spectrum to achieve greater sensitivity to brightness and color. Otherwise, the design and instruments aboard Landsat 9 generally replicate those found on Landsat 8. A bit more on the Landsat satellites. The Landsat 8 and 9 satellites being compared for this study each carry 2 sensors, the operational land imager 2 with 9 spectral bands, and the thermal infrared sensor 2 with 2 thermal bands of varying spatial resolutions. Both the Landsat 8 and 9 satellites launched from the Vandenberg Air Force Base in California, and Landsat 8 was launched in February of 2013 and is the longest continuous Earth imaging mission in history. Landsat 8 was the first satellite with the operational land imager and the thermal infrared sensor, providing seasonal coverage of the Earth's surface with 30-meter spatial resolution. Landsat 8, like the others before it, improved upon previous satellite designs by implementing experimental technology, adding spectral bands to detect clouds and observe coastal areas, in addition to 2 thermal bands introduced with Landsat 8. At the time of its launch, Landsat 8 was one of few satellites available capable of capturing near real-time data, taking 16 days to cover the Earth's surface. So between the Landsat 8 and Landsat 9 satellites, both in orbit now, the revisit interval is only 8 days, which is awesome. Landsat 8's radiometric resolution, which is the ability of a sensor to distinguish between shades values when acquiring an image, is 12-bit, which means it can detect just over 4,000 shades, over 4,000 different shades across available wavelengths. The main improvement from Landsat 8 is Landsat 9's in Landsat 9 is the radiometric resolution, which is now 14-bit. And this allows for the sensors to differentiate between over 16,000 different shades. This improvement is the catalyst for this research project, creating the opportunity to test the Landsat 9 sensor's ability to distinguish features with similar spectral properties. So on that same thought, this is the problem that I identified as the basis for my research, which is water bodies and shadows and imagery can often be confused with burned areas due to their similar spectral properties, affecting the accuracy of burnt area estimates derived from remotely sensed data. Water has low and steadily decreasing reflectance in wavelengths, particularly in the visible spectrum, with almost no reflectance in the near infrared range. This means water surfaces will appear as dark areas with low pixel values when an image is displayed using band combinations that utilize red, green, blue, near infrared, or shortwave infrared bands. And shadows naturally have low pixel values and will appear as dark areas in the imagery as well. So this is my study area. I'll be using the Marshall Fire as a case study. The Marshall Fire ignited on December 30th, 2021 and burned over 6,000 acres in one day. The fire spread quickly thanks to wind gusts of over 115 miles per hour throughout the towns of Superior and Louisville, as well as unincorporated parts of Boulder County, destroying over 1,000 structures and homes, resulting in millions of dollars in losses. The Marshall Fire displaced more than 35,000 people, with only a small portion being able to return to their homes, and 2 people are still reported missing. The cause of the fire is still under investigation, with potential causes related to coal mine fires, down power lines, or human activity. And the fire was extinguished naturally by heavy snowfall overnight between December 31st and January 1st, 2022. So demographics are important to keep in mind to give a human element to wildfire emergency management and response. So here are just 2 relevant statistics gathered from the 2020 census. Boulder County is home to over 330,000 people and has over 140,000 housing units. This is important to consider when thinking about the different stages of emergency management and how remote sensing can provide actionable data to emergency management personnel. A bit more on the geography of the study area. Boulder County is 25 miles northwest of the Colorado state capital of Denver. It's 740 square miles in area and has a pretty diverse geography, physical geography that is. Boulder County is located in the Boulder Valley, where the Rocky Mountains meet the Great Plains. And the land cover and land use types in this area include urban and rural, pasture lands, mountain features, and water features. So a good study area for this project. So the goal of this study is to evaluate and compare the accuracy of burn scar detection and burn area mapping between imagery and spectral data acquired from Landsat 8 and Landsat 9 satellites using the Marshall Fire burn area as a case study. It will evaluate the ability of different remote sensing indices derived from the newly launched Landsat 9 satellite to identify and assess the burn area of the Marshall Fire and compare those results to those derived from the Landsat 8. These are my objectives for the project. So the first objective is to define spectral profiles for the land cover and land use types within the Marshall Fire project area in both sets of imagery. My second objective is to identify and compare burn scars detected in Landsat 8 and Landsat imagery using band combinations and burn area indices. My third objective is to classify the Landsat 8 and Landsat 9 imagery using supervised pixel-based methods. And my final objective is to assess the accuracy of those classification results to identify burn areas. With the increased radiometric resolution on Landsat 9, this study assumes the accuracy of burn area mapping will be better than burn areas identified with Landsat 8 derived data. The ability of Landsat 9 to distinguish between over 16,000 shades will allow for capturing more detailed spectral information for each land cover and use class, which can only improve the classification process. An error matrix will be produced as part of the accuracy assessment to document the number of pixels correctly or incorrectly classified as burn or non-burn areas within the Marshall Fire Study area. To identify the importance of individual bands used for detecting burn areas with spectral indices, a geostatistical regression analysis will be conducted. So I will be using ArcGIS Pro to conduct image pre-processing workflows, the classification workflow, and the accuracy assessment. And I'll be using eCognition to collect spectral profile information. So this is the outline of my proposed methodology, and I'll go into each one of these steps in a little bit more detail as we continue on. So the first step will be to define the study area. The study area will be chosen to best test the ability of the new Landsat 9 satellite to detect subtle differences in spectral properties across various land cover and land use types. Shades similar to burn areas detected in the map will likely be from water and shadow features, which are often confused during classification workflows. The Marshall Fire provides this the right kind of variety in land cover and use types due to its location near urban and rural areas, as well as water features and other physical geography features in the study area. The second step will be to collect and pre-process the imagery. Landsat imagery is available for free and is easily accessible via the USGS Earth Explorer interactive data download site. Image footprints will ideally cover the study area with only one scene, but if not, multiple scenes will need to be downloaded and combined to create a single image for analysis. So on the left-hand side there, you can see I have two different screenshots of the Earth Explorer website showing the Landsat 8 and 9 scene footprints. And I'm pretty sure I can just use one scene for each satellite, but just in case I've loaded a couple there, so I have a few more options. Other pre-processing steps will include projecting the images, clipping the images to the study area to decrease processing time, and visualizing the imagery to best suit classification and indice workflows. The third step will be to create spectral profile interpretation keys of land cover and use classifications. So these spectral profiles will select areas of interest or ground features on the image and review the spectral information of all bands in a chart format like you see there on the right side. Spectral information will be collected for the following land use and cover types, including buildings, water, trees, grass, pavement, roads, and shadows. These profiles will include image properties for red, blue, green, near infrared, the normalized difference vegetation index, also known as NDVI, homogeneity, and contrast values for each of the different classes. The fourth step will be using band combinations to identify burn areas. And those band combinations will be used in the burn indice formulas. The most common burn index is the normalized burn ratio, which is used to detect burn areas and provide measure of burn severity by utilizing the near infrared and shortwave infrared bands. A variation of this will also be used, which is the difference NBR, the difference normalized burn ratio. Band combinations will be used to calculate these indices with possible values between -1 and 1. So a higher value closer to 1 indicates more severe damage and more burn. The difference normalized burn ratio takes the NBR values for pre and post fire calculations and subtracts the post fire value from the pre-fire value to get a severity number. The fifth step will be to perform supervised pixel-based classification to map the burn area. So supervised classification is a process for identifying spectrally similar areas on an image by training sites of known classes and then extrapolating those spectral signatures to other areas with unknown targets. This process utilizes the spectral profiles created previously. And pixel-based classification is done on each individual pixel using only the spectral information available for that one pixel, resulting in a class prediction for each pixel in the image. The maximum likelihood classifier will be used for the study, which assumes that the statistics for each class in each band are normally distributed and calculates the probability that a given pixel belongs in a specific class. So the last big step is to perform the accuracy assessment. So an accuracy assessment will be performed by creating assessment points to ground truth the classified burn area results for both the Landsat 8 and Landsat 9 images. A stratified random points will be created across the Marshall Fire study area and assigned a unburned or burned value. The error matrix produced will visualize the correctly and incorrectly classified pixels like you see there on the right side. The error matrix will also display the overall accuracy for the classification process. The last step in my methodology is to analyze and discuss the results and identify any limitations. So while the Landsat missions are useful for their extensive archive of imagery back to 1982, as well as the rich spectral information collected, limitations of Landsat data include its moderate spatial resolution and the inability to task the satellite to a particular area at a particular time. And I'm sure other limitations might come up as I actually do the research. So my projected timeline is detailed here. Look, it'll take about over 3 months, about 3.5 months to do the entire project, with about a month spent on doing the creating and writing and editing the analysis report. So I plan to officially start the project April 1st and wrap everything up July 15th this coming summer. Some possible presentation venues. The Esri User Conference is set to return as an in-person event this July in San Diego, California. The UC is the largest gathering of GIS community with over 19,000 annual attendees, and presenting the results of this study at the UC will contribute to the larger GIS and remote sensing community. On a more local scale, another option would be to identify a regional GIS or remote sensing user group, or even a regional fire or emergency management group to disseminate my information to. This could be potentially useful and actionable information to share with emergency planners and responders in my local area, which is impacted by wildfires annually. Thank you again for following along with my presentation, and quick shout out to Dr. Taylor for advising me through this process and supporting me and helping me hone my topic into something a bit more manageable. So if anyone has any questions, I'll go through them.
Thanks, Raylyn. It looks like Justin already has a question.
Oh, okay. How do I see that?
You might need to stop sharing. It's
Okay.
easier to see it that way.
Okay. So go ahead. Justin, was it that had a question?
Yeah.
Is it in the chat?
Yeah.
Oh, okay. There we go. Sorry. Have you considered any interactive elements to present your? Oh, like a story map. Yeah, that's actually a great idea. A story map would be a really good way to present it. Definitely with that slider feature, I could display the different classification results on top of the burn area and see how it looks compared to like the ground truth fire perimeter, and that would be a good way to present other than just a PowerPoint. Also, a public outreach, that's a good point too. That could be a part of, if I go the regional user group way of sharing information, I could share it with the fire people in Sonoma County, and they could potentially, implement some sort of process, some sort of workflow in there, and to better, or to use the Landsat 9 imagery to better map fire areas as they're burning up here, because we have a lot of fires. So that's a good question. Austin, will you be comparing the Marshall Fire burn scar? Yes, I will be comparing the Marshall Fire burn scar area between the two, and seeing which, hopefully Landsat 9 is more accurate accuracy for Landsat 8 classification. So I'll be doing an accuracy assessment for both Landsat 8 and Landsat 9, and I'll use the Boulder County, Colorado's fire perimeter for the Marshall Fire as like the truth. And so I'll see how close either classification gets to matching that burn perimeter that they've already created. I hope I'm answering everyone's questions well. We considered evaluating the temperature raster from the Landsat. I hadn't considered evaluating the temperature, the thermal information from the Landsat thermal data. I'm not really sure how I could include that in the classification process. I think maybe if I was using temperature data, I could maybe compare it to the MODIS active fire mapping products that come out of the MODIS satellites. But I don't think I'll be using thermal data for this project.
Raylan, this is JB, and you will have the Landsat thermal data. It turns out that that pixel can be changed to a temperature using the raster calculator. And if you did some searches on the web, you can find the formula, just that.
Oh, okay. That's great to know. I actually had no idea that you could do that. So I will look into that, and that'll be an interesting component to add to the project too. So thank you for that.
Yes.
Okay. Landsat 9 improvements. Yeah, so Steve, is it Steve Keeker? Yeah, so the radiometric resolution improvement on Landsat 9 is like the basis for this project. So I'm hoping that the subtle differences that you note there between water or dense forest areas, I'm hoping that I can highlight that the increased radiometric resolution will also increase the accuracy for burn area mapping. So that's a good comment. I previously used MAR to assess it. Have you thought about also assessing? Oh, regeneration of vegetation post-fire. I hadn't planned on including that, Dan, in my project, but I was going to comment on it in my literature review section of the report, going over how NBR is used in different applications of remote sensing, and maybe talking about how, you know, expanding the project or continuing research could be done to assess regeneration with the new Landsat 9 imagery. Yeah. So, and then there's a link, improvements. Yeah. Okay, I'll check out that link, Steve. I'll save that to check out when I do my project, continue my project. So I don't know if there are more questions coming in or if that's everything.
Looks like that might be it for now. Lots of good questions and great presentation.
Oh, thank you.
Yeah, I look forward to seeing how it turns out.
Yeah.
And there's another link for you.
Okay.
From JB.
Great. I'm going to copy these.
Okay, so moving right along, we'll move on to Max Katabi. So Max, whenever you're ready, you can go ahead and start sharing.
Okay, hi, do you hear me?
Yes, we can.
Okay, I'm gonna share my screen. All right. Do you see the screen?
We do.
Okay, hi everyone. My name is Max Katabi, and I will be presenting my capstone project in the next 15 slides or so. Let's get to it. As an overview for the project, my project will look at the biological and hydrological resources in the city of Lake Elsinore in Riverside County, California. And the goal of the project is to identify areas that are suitable for mitigation banking of jurisdictional waters and California gnatcatcher habitats. Let's start with the definitions. The term mitigation bank usually refers to a wetland, stream, or a sensitive habitat that has been restored, enhanced, or preserved for the purpose of providing compensation for impacts to sensitive resources and habitats permitted under federal, state, or local regulations. The entity that invests in such restoration work is usually referred to as mitigation banker. And the concept is very similar to actual commercial banks that have, they have cash assets, which they can then loan to customers. But mitigation banks, instead of cash, they have mitigation credits as an asset, and they can sell those credits to those who are trying to fulfill their permit requirements or to basically pay their debts in terms of debits. For the most part, these customers of mitigation credits are entities or companies involved in commercial projects such as real estate development or just development in general. There are two types of mitigation banks. One type would be wetland or stream mitigation banks, and the second type is conservation banks. Now, what is a wetland or stream mitigation bank? Wetland or stream mitigation banks, they offer credits to offset ecological losses that happen in jurisdictional waters, such as waters of the US, or in case of California, waters of the state, which are usually regulated and approved by the US Army Corps of Engineers, or in California by the Department of Fish and Wildlife. And in general, California's jurisdiction to regulate its waters is generally much broader than the federal jurisdiction. Usually, state of California takes jurisdiction over most of the natural drainages in which water could flow at any given time. As an example, if you have a stream, the bed of this stream will be waters of the US, and the distance from one top of the bank to the other top of the bank will be waters of the state. And aside from obvious streams, waters of the state also include drainages that are dry or even desert washes. Those could also be waters of the state. And but for the purpose of this project, I will focus on this broader jurisdiction and definition when I identify areas that have potential to become mitigation banks. Then the second type, as I mentioned, are conservation banks. These banks offer mitigation credits to offset losses of endangered species or their habitats, and they are usually regulated by the US Fish and Wildlife or local or state agencies in general. And one of these endangered species in California is the California gnatcatcher, which my project will focus on. Mitigation banks have four main components. One being the bank site, which is pretty much the physical acreage that's being restored, established, or enhanced, or preserved. And the second component is the bank instrument, which is the formal agreement between the bank owners and the regulators establishing liability management and monitoring requirements and the terms of the bank approval, essentially. The third component is the interagency review team, which is the team that provides basically regulatory review, approval, and oversight of the bank. And the fourth component is the geographic area, which is called the service area, which is the geographic area in which the permitted impacts can be compensated for. What are the benefits of mitigation banking in general? Mitigation banking can help with protecting water quality as well as nature's biological diversity. They can offer incentives to landowners and developers to protect natural resources. For instance, they can reduce costs, and they can also save the developers. They can save them time and essentially money. The other benefit of mitigation banks is that they tend to consolidate small and fragmented mitigation projects into one large connected site that many argue could have a higher wildlife habitat value. There are also drawbacks. Many argue that many argue that mitigation banking could threaten biodiversity through consolidation. And basically what the argument is that through mitigation banking, many natural, small and isolated wetlands scattered through a landscape are replaced by one large wetland. And many wetlands dependent plants and animals require a density of small wetlands. So that's the counter argument to the benefits that I was describing earlier. It is also an area of concern whether the natural habitats and wetlands that took centuries to evolve can be artificially engineered in a short period of time. And another issue with mitigation banking, many argue that is that unlike on-site mitigation banks tend to be located far from the sites of impact, and therefore they can't replicate the site being impacted. All right, let's talk about the history of mitigation banking. Basically, the need to protect wetlands was initially recognized in the 1972 Clean Water Act, specifically Section 404 of the Clean Water Act, which requires a permit to discharge fill materials into waters of the US. And later on, the concept of wetland banking wasn't really developed until early 1980s, and then later during the presidency of George H.W. Bush, who pushed for the concept of no net loss of wetlands across the country. And as a result, wetland mitigation banking became an area of focus for regulatory agencies. And the no net loss basically means that if you impact the wetland, then you have to replicate it somewhere else. All right, my study area for this project is, as I mentioned, the city of Lake Elsinore, which is in Riverside County in Southern California. The city limits contain a land area of approximately 36 square miles and a water area of approximately 5.5 square miles. And the population in the city is around 56,000 people. Okay, for this project, I will use the data shown in the slide. I will use elevation data, and which is gonna come from a 2018 USGS LiDAR data that was gathered for the entire Southern California with a relatively high accuracy. And this data will be the main source of my elevation for the study area. I will also use another elevation data with less accuracy, but I want to have a backup elevation data just in case there are issues with the LiDAR data, so I can have a backup elevation to use. I will also use vegetation data. This vegetation data will come from Western Riverside County. And it will basically be an alliance level type of vegetation classification produced by California Department of Fish and Wildlife and California Native Plant Society. And it's a combination of field surveys and aerial imagery. I will also use the USGS Coastal California Gnatcatcher Habitat Suitability Model for Southern California. It's a model to represent gnatcatcher habitats from low to high categories, which is the ranking system that they use in this model. And the other data that I will be using is the public lands, which is from the California Protected Area Database, or CPAD. Which is a GIS data set that depicts lands that are owned in fee by public agencies. I will be mainly using Esri software for this project, mostly ArcMap and ArcGIS Pro as needed. I might use LP360 to analyze my LiDAR data if needed, and Google Earth will be another software, and Microsoft Excel just for general calculations and just producing charts, etc. All right, now let's get into the methods that I will be using here. The project will be divided into 5 main activities mainly. The first step will be identifying non-public lands, and this will use the CPAD data that I introduced earlier. And they will be used basically to identify areas that are not owned by public agencies. And the goal would be to limit the study area to lands that can be purchased by private entities. The second step will be vegetation extraction. I will use the available vegetation data that I introduced, and I will categorize them into riparian and wetland and or gnatcatcher friendly habitats. And these habitats will then be clipped and extracted from the main data to be used in the later steps of the project. The third step will be to delineate drainages. And for this step, I will be using the digital elevation model or the elevation data that I introduced for geoprocessing analysis, such as field sinks to generate data on flow direction, flow accumulation, and to identify streams, stream segments, and watersheds. And then I will use this data to develop a vector representation of catchments and drainage segments and lines, essentially. I will use county-wide vegetation data to identify drainages that are in close proximity to riparian or wetland habitats. And this step will narrow down the number of candidate areas that are suitable for wetland and stream mitigation banking. In the fourth step of this project, I will analyze the steepness of slope for gnatcatcher friendly habitats, as conservation and planting on slopes greater than 50% could require additional work and might not be feasible. So for that reason, the ultimate gnatcatcher habitat will have a slope below 50% while containing vegetation communities suitable for gnatcatcher. And I will use the same DEM elevation data to analyze the slope. And the last step would be to identify the service areas of the bank. And I will use a watershed-based analysis to identify these service areas. And the service area is basically the area that could benefit from the bank as far as the regulatory agency is concerned. Okay, this slide shows the this slide shows the general timeline of my project. I think it's going to take about probably 2 to 3 months to complete this. I'll probably start in late March, and I'm hoping to wrap things up by mid-June, and then have the final presentation somewhere in from June to December of this year. Okay, here are a few of the potential presentation venues. I have North American Association for Environmental Education's conference in Arizona. It's in October. I have the Wildlife Society conference in Washington, California, Native Plant Society conference in California, and lastly, the Association for Environmental Studies and Sciences in Baltimore. And that's the presentation, and that's the project. And if you have any questions, I'll be happy to answer them.
Good job. Thank you, Max.
Thank you.
Looks like a couple questions already.
Okay, let me bring this up. Sorry, I'm trying to find my.
Yeah, you could stop sharing. That might help you find it easier.
Oh, okay, yeah, let me stop sharing. I think that will help. Okay. Do I start from Justin or us?
Yes, start with Justin.
Justin. Okay, how have other researchers approached similar studies? What did they do well and not well? I worked as a wetland scientist for almost 5 years on irrigation bank water controversial. Surprisingly, there haven't been much research in terms of identifying potential banks. I mean, there are specific studies for, let's say, all right, which area is suitable for gnat catches or what's their habitat like. But specifically, I don't think the mitigation banking is that what's the term? It's that popular among researchers, I want to say. So I couldn't find that much information in terms of past studies. So basically, I'm kind of using my experience, and I also talked to my some of the colleagues that I used to have in terms of that had some projects involving mitigation banks. So I couldn't find that many studies, I want to say. I hope that answered the question. What will be the special resolution of the DEM driver? Okay, the DEM, good question. I had the data somewhere. Okay, the vertical accuracy of the DEM will be around 5 centimeters, and the horizontal accuracy will be below 100 centimeters, which is 1 meter. So sub-meter horizontal and below 5 centimeter or around 5 centimeter vertical. Okay, MBM, so as you mentioned, that linking areas are sometimes used to consolidate banks. Will any of your work on that identify such potential links? Actually, that's the those type of areas will be better for financial reasons. A lot of the mitigation bankers want to locate those larger banks that or the larger areas that could be turned into a bank, because you treat them as one object, and it saves you money to basically instead of having multiple segmented bank, you just have one location to focus on, and that increases the profit. So it's a lot of the mitigation bankers want to have a bigger area to work on rather than multiple small segments or portions. So yeah, I think the result of my project will automatically be those areas that are connected and larger in their naturally than the smaller portions, because in those areas you will have, in a larger area you will have more drainages and more basically suitable habitats. And considering my the accuracy of the data, which is I'm looking at the citywide type of information, it will make more sense to focus on larger areas.
I have a quick question. I might have missed this part, but so if you have some habitat loss or wetland loss in a particular area, does the mitigation have to happen nearby or within a certain distance because of particular species, like you're doing with the gnat catcher? How does that work?
Well, that's where the idea of the service area comes into play, which I explained in the slides. The service area, basically you send your application, mitigation bank application to let's say to the California Department of Fish and Wildlife, and they decide if you are approved to sell mitigation credits to to your county, or, basically they decide what area you can sell your credits to. So it's going to be a back and forth with agencies to basically to identify which are the areas that you can service. So, and the other argument, as I explained, the other argument against mitigation banks are that sometimes, you, for instance, in Southern California, if you impact in the lowest, in the southern part of California, and you buy credits from a mitigation bank in let's say in the county in San Bernardino, which is a different type of environment, different habitats, different wildlife, it doesn't really make sense. But some agencies, allow that to happen, and then they argue that some argue that that's not really beneficial to the environment.
And it lets some people justify. Okay, great. Thank you.
Yep.
Okay, looks like that might be it. And I guess I should have been telling everybody, if you can all put your email addresses into the chat in case there are any remaining questions that somebody had they didn't get to ask. If each of you could put your email addresses there, and somebody might want to follow up with you. Okay, so we have one more presentation, Justin Mitchell. Justin, whenever you're ready, you can go ahead and start. So we don't hear you yet, Justin, just in case you make sure you.
Sorry, I have a mute button on my mic, and sometimes I forget to unmute that. It's a kind of a running joke at my job that I double mute myself all the time. You can hear me now?
Now we can, yep, thanks.
Excellent. So my name is Justin Mitchell, and I'm an applications engineer and business intelligence consultant for a consulting company called Black & Veatch. Recently, I've seen an increase in opportunities for supporting municipalities with their lead and copper management solutions. Once I started seeing them pop up, I did some research and discovered that recently the Environmental Protection Agency has published a pretty big revision to one of their longstanding regulations about lead in our water supply. They also are planning in 2024 to release improvements to this rule. So municipalities are kind of scrambling to figure out how they're going to address these changes. Before I get started, I just, I don't want to insult anyone's intelligence, but, all around you are really complicated systems that transmit water to you. When a new subdivision goes in, the amount of analysis that's required to how do we move this water here the most efficient way and make sure that they have the right amount of water pressure. Your water is treated and tested every day. So there's a lot that goes on, and you can think of water systems as road systems. You have mains, which would be like highways or interstates. You have distribution lines, which would be like your local kind of arterial roads, like your major roads. And then you have service lines, which are like your neighborhood roads. Service lines bring water from a distribution line to your house. So that's kind of important. So the overview of this presentation, we're going to go over an introduction to what the lead and copper rule is. We're going to briefly discuss the history of this rule. We're going to talk about how municipalities have handled this rule in the past and the challenges that they're facing with the revisions. We're going to go over the compliance requirements for the revisions. We're going to explain why there's a need for program management. We're going to look at some existing solutions and what they did well and what they didn't do well. I'm going to discuss my goals and objectives for the project. I'm going to briefly discuss my proposed approach. I'm going to show why my proposed approach has improvements over existing solutions. And then I'm going to show you my project timeline. So first of all, we were talking about service lines. And on this graphic, you can see that the service line runs from the road to the house, from the distribution line to the house. There are two sides to this service line. There is the side that is publicly owned by the municipality, which is from the distribution line up to the meter box, typically. And the private side, which is the responsibility of the homeowner usually, which would be from the meter box all the way to the home. So the dangers of lead, first of all, is that it can affect pretty much any organ or system in your body. In young children, infants, elderly people, and pregnant women are especially susceptible to lead in the water. It would take the entire presentation to list the amount of health concerns related to this. The sources for lead exposure to us in our day-to-day lives are that it can enter our drinking water when pipes and plumbing fixtures that contain lead, they corrode. And this really is driven by the acidity, low mineral content, the temperature, the material of the pipe. The pipe doesn't necessarily have to be made of lead. It's called the lead and copper rule. So some old houses have copper pipes, but they use lead solder joints, or they use lead fittings. So even if you don't have a lead pipe, you can still be exposed depending on these types of factors. In 1991, that was the first time that the EPA really made a big change to any type of regulation. They were already kind of monitoring it with, testing water and things like that. But in 1991, they took the acceptable parts per billion from around 50 to 0, meaning that if you test water and it shows any sign of lead, you have to take action. So that was a big thing for municipalities. But it was relatively easy to manage because it was reactionary in nature. The revisions to the existing regulations, their goal is now to have a proactive approach, which means that we want you to identify all of the lead pipes in your system. And that means building a lead service line inventory and then developing a lead service line replacement plan. So instead of just being able to test and deal with it when they find it, municipalities are now having to take, like I said, this big proactive approach to find this lead. In addition, this rule revision had a lot of public outreach requirements as far as like notifying the public and informing them, giving educational materials, things like that. I've already briefly discussed the history, but I'm going to go into a little more detail. Again, the rule in 1991, it reduced the maximum contaminant level goal from 50 parts per billion to 0. It also said that all community water systems need to be addressed, which was not always the case. In 2007, there were some enhancements, and these enhancements involved mostly public outreach and a lot of revisions to language based on legal concerns, right? So, just kind of revising the language of the rule, because in these types of projects, municipalities will have a lawyer present at all times because they're, they're very expensive to even just to monitor. It's an expensive project, and there are grants and fundings, but it requires a lot of time and a lot of program management. In 2021, again, this is where we see the first major revision, which would be the focus on 100% service line replacements. So it also introduced a focus on critical facilities, which would be elementary schools, maternity hospitals, elder care facilities, things like that. Again, they want a service line inventory, which I'll discuss why that's such a big challenge in a moment. The proposed challenges, the proposed improvements in 2024 to the rule are when you have to have your lead service line inventory completed. So they're letting us know with this revision that you're going to have that. By 2024, they want everyone to have it. And by the way, the enhancements, revisions, and improvements, that language is coming directly from the EPA. That's how they designate these different phases of the rule. Historically, the municipality solutions have been pretty simple. You do a water sample and you write it down on a piece of paper and you submit a report, typically an Excel spreadsheet, every month. It's essentially that the replacements would only happen if the samples reached above that threshold, right? So if there was no lead, they didn't test it. Lead service, or sorry, the the lead service line inventory is a challenge because it's not uncommon for municipalities to not have any spatial data related to their service connections or what they call the laterals, the service lines. It's just not something that most people have. They'll have GIS data for their distribution lines, and they'll have it for their mains. But this, it's almost always incomplete, or just they don't do it. They don't worry about it. So now they're all struggling because they have to go out and do these investigations and identify lead in these service lines, but they don't have the GIS data to do so. We've kind of talked about some of the compliance requirements, but let's go over them real quickly again. With the revisions and the upcoming improvements to the rule, we have service line replacements. We want 100% lead gone. There's increased sampling requirements. They want us to prioritize historically underserved communities, which means census data is important. It's a very, difficult subject because you want to pick somewhere that has objectively the most likely chance of having lead service lines because it has houses that were built prior to 1986, or it has old distribution lines, so you can assume that the service lines are probably old as well. But if it's an area that is primarily white and with a high median income, and there's another area that is similarly at risk, but is a majority in ethnic population or lower income, they want you to go there. The public outreach requirements have been massively increased. They want you to report all of your findings. They want you to report your lead service line inventory, and they want you to provide educational material to the public, even more so than in the 2007 rule. They're also requiring support for affected customers. So within 24 hours of identifying and replacing a lead service line, you have to provide a pitcher filter, like a Brita filter, and enough replacement filters for 6 months. You also have to collect a lead tap sample from the kitchen sink 3 months and 6 months after you've replaced that line. So why do they need program management? So because they're required to manage these new requirements, it's overwhelming. They don't have the GIS data to do it. They don't have, even if they have a GIS department, they don't have the bandwidth to develop a solution, and they definitely don't have the time to go through an iterative process to make sure that they're doing it correctly. In addition, a lot of these people at these municipalities are not experts on the lead and copper rule, and why should they be? It's not something that they're really responsible to know in and out. We'll talk about a little later, but there are a lot more aspects to this program, such as right of entry to the customer's home, notification of the lead discovery, and notification of the service line replacements, and things like that, that need to be tracked. In addition, all of those work activities that need to be tracked should be tied to that service connection. We want to show the EPA, if anything ever came up, again, talking about some of the legal concerns, we want to show that we did contact this customer and we did everything we were supposed to. And if it's, on a spreadsheet on someone's computer, or if it's written down on a notepad, it's likely it might be lost. The other reason that there's a need for program management is a single platform for consistency and easy implementation. Almost every municipality I've worked with in 10 years of consulting has had a GIS department, or at least had access to an ArcGIS online account. So rather than using some sort of computerized management system that a lot of people use for like taking service requests, or like essentially a call center, and then having that data stored there, having the GIS data here, and then having a sub-consultant who performs a field investigation store the data there, we can have it all in one place, and we can have referential integrity between these elements. So the pros of the existing solutions. I did some research on consultants who are currently doing this, or currently pursuing this type of work. And in addition, Esri, if you guys aren't familiar, they have a solutions page where they kind of make some simple pre-canned solutions for typical things. If you work for a municipality and you want to have a tree inventory. Well, they probably have a tree inventory solution. It would be a blank schema, perhaps a field map, and maybe a dashboard, operations dashboard, things like that, that you can append data into or begin collecting data. So what these existing solutions did well is excellent reporting concepts. This is a mashup of screenshots from some of the Esri solutions and implementations. And it's really cool for an asset manager to be able to see their city broken out into zones based on pipe install date. A heat map of the lead service line hotspots is excellent because you can quickly see where these areas are, and then you can identify similarities with other areas. I saw a lot of creative symbology of how to present so much information in a digestible way. And I really enjoyed the schema for the service line inventory. It was very well developed. What they didn't do well, for Esri's lead service line solution, there's absolutely no related tables. It's just one feature class, and that is a point feature, which represents the service connection. It only manages the discovery of lead service lines, so it doesn't touch on any of the other compliance requirements that we discussed prior. There's no method for recording customer interactions, and it's not leveraging the latest technology, which would be Arcade, the programming language, which if you don't know, it's Esri's proprietary programming language that is essentially a mashup of JavaScript and Python. And you can do some pretty fascinating things with it as far as symbology is concerned. So you can define variables for your different coded domains. You can enumerate them, and you can do differences in date. So you can say if this attribute equals X, and the difference between today and the last investigated date is 60 days, I want you to symbolize it this way. So with that, you get real-time data, and not just from editing an attribute. You get real-time data as time goes on. They're also not leveraging hosted views, which again, if you're not familiar, a hosted view would be a visual representation of a table join. So you have a global ID on one feature and a parent global ID on the other. And the parent global ID is stored in a table. So when you join these two, rather than just adding them on to the attribute table of your existing feature class, you create a new layer that has all of those attributes. And again, using Arcade, you can now symbolize based on records in a related table. You can also be creative in how you use those hosted views, as far as keeping only the most recent record, keeping all records, keeping records based on a filter, things like that. They're also not using the experience builder, which is Esri's, I would liken it to WordPress or another simple website builder. So rather than using their built-in operations dashboard, you can use HTML, you can use the Arcade language, you can embed other content and really create a dynamic page for whether it be for program management or for, public outreach. The other consultants, they're essentially just repackaging Esri's solution. I didn't find anyone who's doing anything different. So they all have the same gaps in compliance assistance. And I'm not going to say who this screenshot is, but this is an actual dashboard that a consultant was trying to show as marketing material. I know it's kind of hard to see, but if you look in the legend, those are not friendly names. That's all lowercase with underscore still that says service contains lead, true or other. So there are so many other factors. It could be galvanized needing replacement. It could have been copper with lead solder joints. It's just tracking whether it's lead. The elements are not sized well. Those numbers are smaller next to each other. And I don't know if you can tell, but in the bottom left there, that's actually a pie chart that they're trying to show. And it says excellent is 0.69%. And null is the rest of it. So if they had used Arcade, they could have taken all those null values and forced them to be called not investigated rather than null. Nobody wants to see null, especially in a public-facing dashboard. My goals and objectives for this project, first and foremost, are to provide a cloud-based GIS solution for the lead and copper rural revisions program management. I want it to address all of the aspects: the customer coordination, the field investigations, the service line replacements, property damage, I also want to create this system in a way such that it enables municipalities to simultaneously meet the compliance requirements of the lead and copper rule while updating and creating their service inventory. So again, I mentioned most municipalities don't have a service line inventory. So by going with my solution, when it's done, they will, and they can continue to use that. They probably would want to export that out to another feature. That way it doesn't have the same schema and relationships that the lead and copper rule requires. And, they can just be on either a automated Python update schedule, or they can do a manual schedule. Once a month, we take new service lines that have been service connections that have been GPSed and, populate them into our working data. And by the way, this is a screenshot of a prototype I'll show later of what one of my experience builder dashboards looks like. So my proposed approach is to generate service connections using their financial systems and parcel data. So it's very uncommon for municipalities to have complete service connection data, but they really care about their money. Water is a big generator for them. So they're going to have financial systems that can be geocoded. They also have parcel data that's very important for tax rolls. So between the two of those, there are many ways that we can create service connections. You can see on the right here, some of my test data, I created service connections, and on the left, we symbolize what the private side is, the utility owned side, and on the right, we symbolize what the public side is. So very quickly, you can look and see what the lead status is. I also want to prioritize the sites based on likelihood of lead presence. So this would be a weighted scoring system. So a weighted scoring system is essentially a way to provide a rank, maybe 1 through 5, to based on a value. So if the median income falls within this range, this service connection gets a 3. And then once you've scored everything, you multiply that by a decimal representation of the weight. You sum them all together after that, and then you have what your final score is. So by doing this, we can weight things that are more important, such as the building age, the pipe material of the distribution line, the install date of the distribution line, and that can make up 60% of the scoring. Whereas the census data and the social justice information might only make up 30 or 40%. So by doing that, all things being equal, we'll choose a disadvantaged community first, but all things not being equal, we're going to go with the most objective choice. We're going to use Esri's cloud-based applications for all required workflow elements. That includes Survey 123. Of course, we're going to use the desktop application Survey 123 Connect because it offers a lot more benefits than the drag and drop web interface. You use an Excel sheet to format your device, format your form, and you can do a lot more with calculated values, pre-populated values, conditional formatting, things like that. Lastly, all the reporting solutions will be automated with custom Python scripts. There are a lot of different libraries that can be used for this. One of them would be the docx module. So we can read things out of the database driving the hosted feature services, and we can populate templates. So if the EPA has a template they need for when you are reporting a lead discovery, we can make it match that exactly. If you have internal reports that you'd like to see, we can make graphs, anything that you want to see. Of course, we have dynamic dashboards that'll be doing that at the same time, but if you need static copies every month of where we were for program management, that can be accomplished. The workflow categories that I've developed for this to make it a little easier to explain and also to separate out the development are the pre-processing category, which would be workflow elements related to preparing project data, the weighted scoring system, configuring the ArcGIS online environment. The administrative are all workflow elements related to customer coordination. That's lead discovery notification, investigation scheduling, Brita filter delivery, things like that. The field staff category is any workflow element that's related to performing field investigations, responding to property damage complaints, and performing replacements. The management is where key performance indicators come in line. A key performance indicator or a KPI is simply a metric that you can use to determine the progress of a project. So I want to know that my crews say that they can do 6 field investigations a day. And we, want to have X amount done this month. So week to week, how are we doing and what were the statuses? There's also the task management element of being able to see where right of entry was approved, but an investigation hasn't been completed, or where lead was discovered and a replacement hasn't been completed. Final category would be public, and this is workflow elements related to public outreach and support. The general workflow for the field investigation specifically, which is the most important part, building this lead service line inventory, finding out where our service connections are and what their material is, what ones are at risk. So again, data processing is where all that geoprocessing takes place for the weighted scoring system. The request access is the investigation scheduling. That's where the administrative staff is going to reach out and record whether or not the customer approves us to go onto their site and do a field investigation. The field investigation is self-explanatory. The reporting is whenever the data is dynamically driven to those dashboards for the task managers and program managers so that they can then use that to inform the public or coordinate with the admin staff for additional follow-up. This is a brief workflow document that I threw together because I have a difficult time writing things until I start doing them. And so this kind of lays out what the system would be. So, we would pre-process the data. The administrative staff would use a custom dashboard to schedule field investigations. The field staff performs them. If follow-up landscaping or property damage is required, there's a dashboard for that management can view. If lead is discovered, they're going to contact the customer. When the replacement is complete, admin staff contacts the customer again. When this field investigation is performed, it drives 3 dashboards: the task management dashboard, the program management dashboard, and the public outreach dashboard. The goal of the public outreach dashboard is to inform them why we're doing it, how we're doing, and allow them to submit inquiries. My improvements over existing solutions, I've kind of already gone over that a bit, but I'm going to explain a little bit more. This screenshot here is an example of the administrative dashboard that I've developed. So on the left is a list that shows 123 Fake Street as everybody's address, and it shows the status. So if they were contacted and there was no answer, that's going to require that the admin staff put in a scheduled follow-up date. It's likely that we'll say that follow-ups are every 3 days after you call them. So that might be an automated process that we can take off their hands. And then after that, the list is sorted by people they haven't contacted. And that list will be in ascending order of the highest priority. There's also a filter icon. So if they want to see people they haven't contacted or people they have contacted, people they need follow-ups, they can filter that. If they scroll to this map, they'll be able to click on something, any one of these service connections, and then it will automatically populate that embedded survey 123 form with all the relevant information. It also ghost passes values for the global ID of that service connection. They don't see it and they don't have to enter it, but now this record will always be tied to the service connection. The main ways that I'm improving this is that it addresses all compliance requirements for the lead and copper rule. It provides referential integrity between the activity records. It improves service line inventory management. I'm leveraging the latest technology. I'm providing real-time data, not only in the fact that it's reported within 30 seconds. If an administrative staff member speaks to someone who approves a site, the task management and field crews can see that within 30 seconds. All they have to do is zoom out of their map and zoom back in to refresh it. But in addition, we're using that arcade symbology. So we're able to symbolize based off a lot of complicated values. So, if lead was discovered, but replacement complete is null, I want you to symbolize it this way, right? If lead wasn't discovered, things like that. We're improving workflow efficiency by giving everyone a single dashboard that they're responsible for. Now, these dashboards might have multiple pages that they can click through, similar to a web page, but it's all similar to if you've ever used Power BI. You can make it very much one landing page. So to tell the administrative staff that they're responsible for 5 different dashboards for all these different aspects, that's overwhelming. But if you tell them it's one dashboard and they just have different pages that they can click on and transfer through, makes it a little more digestible. In addition, these pages on these dashboards are going to be focused on one thing. This is the dashboard page for reporting lead discovery notifications, and that's all you'll do there. In addition, doing this up in ArcGIS Cloud, we're able to do user roles and permissions. In the ArcGIS Online environment, everybody's set a role, which allows them to edit certain data or publish data. But we can take that further with groups. So, in the public outreach dashboard, I wouldn't share any actual data. I would share views of that data, and I wouldn't enable pop-ups, right? So we only want them to see what we want them to see. It also enables me to share things to different groups of those workflow categories and provide different symbology. The admin staff, they might not care about what the project management staff cares about. My project timeline is to finish the prototype this month. And in April 22, I'm going to be doing focus groups for user testing, both internally at my company and with a couple of prospective clients. We already manage some work for these clients. They trust us. We do good work. So, the interest is there. And so we can do some focus groups. In May 2022, I'll be doing refinements after my user testing. And in June and July 2022, I have some presentations. We do have an Esri rep that we meet with once a month. And I'm going to, put a bug in their ear about doing a Esri user conference and hopefully an Esri blog post. I'm also scheduled to do a company presentation, I believe early June. And that's to show people what I can do, not only for the lead and copper solution, if they have any potential clients for that, but also for other workflow developments. This is something I really enjoy doing. Lastly, hopefully there will be client workshops and proposals and training if we get some work. Now the slides everybody's been waiting for. I know this is what you really want. These are the references. And if this isn't enough for you, I got references continued. So there's plenty of those. The last thing I want to do is show you a public outreach example, and then I promise I'll stop talking. So this is something that I threw together rather than a typical operations dashboard or web application, which is not a bad way to approach it, but I think that a scrolling web page is something that people are more familiar with. When you have to, we're data people, so when we see a widget, we explore it. I've dealt with people who have used web applications that I've made, and even with pop-ups and information and a splash screen, they still can't figure out how to do what they're supposed to do. So this public outreach dashboard is created to tell a story. What are we doing? We're creating a lead safe community. How are we doing? This is our progress. Why are we doing it? Lead in your health. I have a little infographic from EPA. These learn more links don't go anywhere, but they could link to the letter, any kind of documentation. They could even link to a municipality's data library or have them download a PDF, whatever they want to do. So what action are we taking? And we let them know the different things that we're doing to help prevent lead. And then when they get down here, they have a map that they can scroll around on. And if they click on a lead service line, it'll populate their name, their address. They can change the phone number that we have on record if it's a better way to reach them. Can add an email if they like. They can say that they're doing, they want to know about their investigation scheduling. They never got their picture filter. There was property damage or something else. This is read only, inquiry date and time. And they can put in customer comments. Again, it's ghost passing that global ID from the service connection, so it'll always be connected. And when they submit this, it would go to the administrative dashboard page that's designed to respond to customer inquiries. So that's it. This is the experience builder, and this is how all of the workflow elements are going to look consistent. They're all going to have the same branding and colors, and that's it. Thanks for listening.
Great. Thanks, Justin. Raylan has a really short question for you there. Just kidding.
Awesome.
She has some really good questions there. So you start there and we'll see if we get any other questions.
So she says, very excited for your project, Justin. I work for city government in our utilities department, and our director is starting to ask a GIS to come up with a solution for copper lead replacement program. I will say Our city spent 5 years collecting underground utility data, including lateral services. No small feat, as you mentioned. Do you envision your program management solution integrating with an asset management solution? Have you read up on Esri's evolution of the utility schema going to a single feature class for each shape type? They're calling it the utility network, where, for example, every utility that is a line type will be a single feature class with subtypes and the definition queries to addresses or to address all the different kind of pipes, etc. Will this maybe change your approach? So the first thing I want to address is Esri's utility schema. And no, this will not change my approach, because the purpose of these points is to develop the lead service line inventory. They can be appended into that point that has valves, fittings, all of that other stuff in the utility network, and field maps. So they can keep the features that are not important, the attributes that are not important, and field map the ones that are: install date, material, things like that. As far as integrating with an asset management system, yes. So the way that I developed this, if a municipality wanted to use CityWorks instead, or another computerized management system, I can accept using webhooks and JSON. I can populate survey 123 forms, or I can populate feature classes when they close an inspection or a service request, and some of those things like Rocksteady, CityWorks, things like that. So the schema was built in mind to be a one-stop Esri cloud-based solution, but knowing that municipalities need to be dynamic, I did build it to where it would be fairly easy for me to implement it with someone who just really wanted to use something else. Were those the asset management systems that you were thinking of, something like that?
I'll just unmute myself. Yeah, that's exactly what I was thinking about. So you answered my questions perfectly. Thank you.
All right. Well, I'm a talker. I'm sure I went over and everybody's sick of this. So thanks.
Looks like one more question.
Would there be aspects of this project that could be adapted for lead paint abatement? I live near Baltimore, which still has a lead paint problem. Also, considering Baltimore's recent water billing woes, using water billing information to provide an initial load of data may prove troublesome in some cities. What else would you consider? Right. So what we would consider there is creating what they call a stacked parcel. So typically a parcel is just a polygon, right? But you can create a stacked parcel, which would, if it's a condo, it would have a polygon, not a multi-part geometry, but essentially an overlapping exact copy of that geometry stacked on top of each other. From there, we could generate center points off of those parcels. And then there are tools that you can do to distribute the points. So it'd be a little goofy. They would have to go in the field, and when they're doing their investigations, they'd have to click on that service connection and hopefully have a Trimble unit or some type of GPS so they could actually GPS the location. Or if it's a big meter bank, you could just have your GIS specialist, like someone kind of low on the totem pole, go in and just line them up. That way it makes sense visually, rather than having them all stacked on top of each other. So that's an option. The worst case scenario is that I don't have financials information and I don't have good parcel information. I can't create stacked parcels. In that case, I would just geocode a point for all of these addresses. And when the field crews get out there, if there are additional service connections at that point, they would use the collector field app to create however many service connections are there. In that case, they would have to populate the information related to the customer and things like that. So that could prove challenging because then we're not getting right of entry. So in that case, what I would propose is an additional phase to the municipality, that you need to go door to door to these places that are condos or duplexes, and you need to take a survey 123 form, and we need to drop a point on the service connection and then create a customer record saying, hey, we got in there. So those are some of the ways that I've been brainstorming on how to, those are some of the ways that I've been brainstorming, handling those different scenarios where it might not be that great. As far as lead paint abatement, I don't know anything about that workflow, but truly you can do anything with this. If I had somebody who wanted to do bike trails, I could, slap a GPS on them and let them ride the bike with tracking so that it, tracks the line that they drive. And then we could, have them stop and record damages, and then we can have a public outreach map for that, where the public can see what the status of these bike trails are, and the task management crews can send crews out to fix it. So there's really no limit, and that's kind of why I want to do more than one presentation, because I want to show people in my company, hey, we have a solution for lead and copper, but also I love this. I love custom Python solutions. I love custom workflows. It's why I have the job that I have. So yeah, I don't know much about lead paint abatement, but I'm certain that we could build something.
Great. Thanks again, Justin. It's nice that it, like you said, it could have a lot of other uses as well. So great job. Okay, well, like Raylan, I'm also excited to hear how this goes. But thanks to everyone for presenting this evening. I just put the peer review evaluation form link into the chat. So please do make sure you fill one of those out for everybody else in the class, including the presentations from Friday. The recording of the Friday presentations is already up in the Capstone library, and the one from tonight will be put up there as soon as it's done processing. So great job, everybody, and have a good night.
Thank you. Goodbye.